Welcome to MH2801 video segment on the class of a partial differential equation. Earlier on, we have learned how to classify a partial differential equation according to its order. Now let us learn how to classify a partial differential equation according to its class. To explain the concept of a class of a PDE, let us consider the most general second-order linear partial differential equation that we can write down in terms of x and y. The coefficient of the second partial derivative with respect to x is a. The partial del 2 psi over del x del y is 2b. That of del 2 psi over del y square is c, and then for the linear terms, del psi over del x, we have the coefficient d, and then del psi over del y, we have the coefficient e, and then a constant f, and then this is the most general second order partial differential equation in x and y that we can write down. Now, this particular second order PDE can be written in three different standard forms depending on its discriminant. That decides what is the appropriate change of variables that we can use. The discriminant capital D is given by AC minus B square. Here you see that it depends only on the coefficient of the second order term. And the reason for this is because lower order partial derivatives can be made to vanish through an appropriate change in variables. Now, the three classes of linear PDEs are elliptic PDE if the discriminant is greater than 0. In which case, the standard form for the PDE is actually the Laplace's equation, which we will write as del 2 psi prime over del x prime square plus del 2 psi prime over del y prime squared equals to 0. We can also get a parabolic equation through a change of variables if the discriminant is identically 0, in which case the standard form is the diffusion equation, which we can write as del psi prime over del y prime equals to d del 2 psi prime over del x squared. Now in this equation, the capital D is actually just another constant, so it's a poor choice of notation. It's not the discriminant. The last class of linear PDE is hyperbolic, and this occurs if the discriminant is less than 0, in which case the standard form of the PDE is the wave equation, which we write as del 2 psi prime over del x prime squared minus del 1 over c squared del 2 psi prime over del y prime squared equals to 0.